suppose I have a population of individuals, and I'm trying to differentiate children from adults based on a couple of variables. So I have two classes, adults and child, and I have two attributes to represent each individual. I have their height in centimeters and weight in kilos. So, and I have some training examples. So somebody has labeled some individuals and gave them to me to construct my classifier. So what the training examples in this case will look like is they will be triples, the height of individual I, the weight of individual I, and then Y is the class. Are they an adult or are they a child? Let's say I have 16 examples, 4 of them are adults and 12 of them are children. So let's see what estimation for naive Bayes actually looks like in this case. So in naive Bayes, the first thing you're going to estimate is the prior. Remember, that's a priori probability of Ebola, very important factor. In this case, and the way you estimate the prior is actually really, really simple. Right? You count how many observations you had from one class, count how many observations you had from another class. So in this case, I had 4 adults, so the prior for an adult is 1/4, and the prior for a child is 3/4. Next, I have to construct the model. So assuming they're an adult, what is the model for the height and the weight? And assuming they're a child, what is the model for the height and the weight? Now, height and weight are real numbers. Right? I cannot just count how many adults had a height of exactly 182.3 centimeters, right? Because there might be none. So I cannot count. So what I'm going to do is I'm going to assume a continuous model. I'm going to assume that the heights and the weights of the individuals are modeled by a Gaussian distribution. So for a Gaussian distribution, all I have to do is I have to get the mean, I have to get the variance, and once I have that, I can compute the probability for any height and any weight that I want. So how do we do that? Let's say we do height in adults. We only have to compute the mean and the variance of the Gaussian. So the mean, Nigel has just gone through the estimation, is just the average of the heights, but not across all individuals, only across adults, right? So I go over all individuals which are adults, take their height, add it up, divide by 4, and that's my expected value for a height of an adult, the mean. And this is my variance. Again, I go over all adults, take the height of an adult, subtract the average height, square the difference, add it up, divide by 4. That's my estimate for the variance in the height of adults. Then I do the same thing for the weights, and I get 2 more parameters. I get the average weight of an adult and a variance or standard deviation in the weights of adults. And then the next thing is I do the same thing for children. So I repeat exactly the same estimation, but now for children. For the height of a child and the weight of a child, I get the mean and the variance.